Okay, this is the warm-up for today. You guys need to do this in your notebook, not your book. So you'll have to write these problems by hand. Go ahead and pause the video. Give yourself a good 3 to 5 minutes to do this on your own and try all of these first. If you're just watching the video and just watch the answers don't really matter. What matters is you trying on this because you guys are going to have to know how to do these. So this is the third day that we have done these type of problems for our warm-up, so you should be getting pretty good at this by now. If you don't remember how to do these, go ahead and go to page 221 and look back at what we did for these before. Also in your notebook you should have these from yesterday as well. So go ahead and pause. Okay, this first one, all of these, you guys, they're h of something. This is your h function. So when you're finding something like h of 3, you're plugging this 3 in for x. So you're going to have h of 3 equals 5 times 3 minus 2. Remember, when you plug something in, you need to put it in parentheses. So this is 15 minus 2 is 13. So that would be your final answer. The rest of these, remember, you're just looking at that h of part and ignoring the rest from the beginning. So we're going to find h of negative 2. So we have 5 times negative 2 minus 2, which is negative 10 minus 2, which is negative 12. So now, this is where you're going to put that in there. So we're going to take away the h of negative 2, and we're going to write negative 12, which is negative 2 times negative, or positive 2 times negative 12 is negative 24. That's your final answer. Okay, we're going to do the same thing on the next part. You're going to ignore these other pieces, and we're going to find h of 1 first. So h of 1 is 5 times 1 minus 2, which is 5 minus 2, which is 3. So now we're going to fill that in. So now right here, instead, we have 3. Whoops. So we've got negative 1 times 3 is negative 3. Negative 3 plus 5 is 2. We're going to do the same thing for the next one. Ignore these other pieces, and we just have to find h of 0 first. So we have 5 times 0 minus 2, which is just negative 2. We need to replace it now. So this is negative 2. So we have 5 times negative 2 is negative 10. Negative 10 plus 5 is negative 5. If you're having a hard time getting these answers, make sure you're using your calculator. We've had a hard time with these negatives and knowing which way that's going to go. So make sure you guys are putting these in your calculator if you didn't get those answers. Go ahead and pause and fix those in your notebook if they needed fixed, and then you'll go to the next section. We are on page 227. So our learning goals are for today are we will determine the effects of the graph of a linear function when f of x is replaced by a times f of x. So before we were doing f of x plus d, which meant that we were adding or subtracting something from those y's, so it was moving up and down each time. Now we're going to be multiplying by something. So our I will graph linear function transformations expressed symbolically and show intercepts. Remember, expressed symbolically just means this. So you're going to have to graph something like 3 times f of x. So that's a symbolic representation. Okay, just a reminder, we're still on page 227. So it says that vertical dilations of functions impact the graph of the linear function f of x equals x. Remember, they call this, you guys, the basic function. And yesterday we found out this doesn't have anything next to x, so there's a 1 there. So the slope of the basic function is 1, and the y-intercept of the basic function is 0, because we've really got a plus 0 there if there isn't anything there. So we're doing all of these transformations, which in this case is a dilation of the basic function. So this first problem says, suppose the output values of f of x change by a factor of 4 to create a of x. The big thing here, you guys, with these directions is this word factor. Can you guys draw an arrow to that and write dilation? Because if you see something that says factor, that means dilation. Dilation means that we are going to multiply. So it says sketch the graph of a of x and complete the table of values. Yesterday we did translations, which was just moving up and down, and we had that table that we filled in, but we talked about how with translations we really don't have to fill that table in. We could just move it down or up by however many we needed to. In this case, you guys, with dilations, you're going to have to fill in the table and graph those points. So right here you can see our x values are staying exactly the same. But what we're going to do to our y values, because it says factor of 4, is we're going to now take f of x and we're going to multiply that by 4. So to get my value over here, I'm going to take negative 2 times 4, which is negative 8. I'm going to take negative 1 times 4, which is negative 4. Here I'm going to take 0 times 4, which is just 0. 1 times 4, which is 4. And 2 times 4, which is 8. Can you guys go ahead and pause and write that stuff down if you didn't already? Because I'm going to erase some of that and make it look a little simpler. But I want you to have that work on your paper so you know what that means. Okay, so these are negative 8, negative 4, 0, 4, and 8. So we took all of those y values and we just multiplied them by 4. Now we just have to graph those values. So we're going to graph negative 2, negative 8. So negative 2, negative 8. Negative 1, negative 4. 0, 0, 1, 4, and 2, 8. If I connect those dots, this is my line, which should have arrows on the ends of it. So here's my line. As you guys can see, that's a little tough to just graph from the graph. So on these ones, you're going to have to use that table, and actually your test has a table just like that that you have to fill in before you do the graph. You guys also have an exit ticket over this tomorrow, and you're going to have to draw the table on there before you do the graph. So we're going to do a couple more of these. Go ahead and turn to page 228. These are the same directions. It really looks the same. You've still got that basic function graphed. You've got your tables not filled in yet. But we've got something different. It says, suppose the output of f of x are changed by a factor. Factor means dilation, which means we're going to multiply, of 2/3 to create b of x. We actually forgot something on this other one, you guys. We should have labeled this a of x because this was our new function. So go back and pause this and label that if you didn't. We also forgot to actually do part B on here too. So it says identify the slope and y-intercept of the function a of x, then write the equation for the function a of x in general form. Guys, general form is not what we call this. This is slope intercept form. I don't know why they call that in our book, but it's slope intercept form. So we have to find our slope and we have to find our y-intercept to be able to fill that in. So our y-intercept is still right here. It's still on 0, 0. So our y-intercept is still 0. However, we do have a rise and a run here. So I'm going to rise 4. So my rise is 4. My run is 1. This is my slope. 4 over 1 is just 4. So my slope, or m, is 4. My y-intercept, or b, is 0. So we have a of x, because that's the name of our function. Remember, we talked about how a of x, or f of x, or any number of x is the same thing as y. So a of x is the same thing as y, it's just function notation. So we have a of x equals 4x plus 0. You don't really have to have that plus 0 there, though. Alright, back to the other problem. We won't skip part B this time because part B is pretty important. We need to make sure we're doing that. So remember, this is a scale factor of 2/3. We're going to multiply everything by 2/3. In your calculator, it depends on which calculator you're using. If you guys have those white and blue ones, you guys know how to put fractions in there. Some of you do. If not, that's not a big deal, right? We can use a parenthesis, 2 divided by 3, okay? You can type it in just like that. That's the exact same thing. The big thing is make sure you have those parentheses on there. If you don't have those there, it's not going to work. So we're labeling this new function b of x when we're done. Our scale factor or factor is 2/3. So we're going to take 2/3 times all of these y values. So to get this value, we're going to take -2 times 2/3. Okay, if you do type this in your calculator, you're going to have to know where that fraction button is at, but you don't really have to have a graphing calculator for this, because when you multiply fractions, if I have -2 times 2/3, this is -2 over 1. If there's something there just by itself, it's over 1. You can just multiply straight across. We're going to have -4 over 3, because you have -2 times 2, 1 times 3. So this is just -4/3. Remember, we want this as an improper fraction. We don't want this as a mixed number. Please don't make this -1 1/3. We don't use mixed numbers anymore, really, after middle school. So this is just -4/3. I'm going to erase this and just write my -4/3 here. If you guys need to be able to know what that looks like as a decimal to graph it, go ahead and write these little curly equal signs. That means approximately, it's approximately -1.3. So that might help you graph that a little bit better. So we're going to do the same thing again. We have -1, so -1 times 2/3, which is -2/3. Because we're multiplying straight across. So -1 times 2, 1 times 3. So -2/3 is approximately 0.6, -0.6. Then we've got 0 times 2/3, that's just 0. 1 times 2/3 is just 2/3, which is approximately 0.6. And 2 times 2/3, we have 2 times 2/3. So we've got 2 times 2, which is 4, 1 times 3, which is 3. So just 4/3, which if you put that in your calculator, it's approximately 1.3. Okay, so we need to graph these now. I'm going to erase some stuff just so this doesn't look so complicated. Go ahead and make sure you have this in your book before we go ahead and put these on the graph. So go ahead and pause if you don't already have that. Now we're going to put these on the graph. So we're going to graph this first point. So we have -2, -1 in like a third of a box. So -2, -1, and a third of a box is kind of right there. So we're kind of being pretty approximate here. We've got -1 and negative almost a half of a box. It's a little more than half of a box. So -1, -0.6, or -2/3. 0, 0. And then we've got 1 and 2/3 is our y. And then we've got 2 and 1 1/3. So if I go ahead and make my line, this is about what it's going to look like, and it's going to have arrows on the end. Notice when we do these dilations, you guys, they're not parallel lines anymore like they were with the transformations. With the transformations, our result was a parallel line. These ones are going to cross at some point. So our next part is identify the slope and y-intercept of the function b of x. We have to label this b of x. And then write the equation of the function. So we have to find our slope and y-intercept. Our y-intercept, you guys, this is still going through 0, 0. So our y-intercept is 0. And then we have to find our slope. Our slope, you guys, I'm going to be honest, is tough with this one. Remember, this zeros are b. You can't really look at that graph to do it because you don't have really any nice points. If you do look at that line on there, you guys, that I drew, this is going to be a pretty nice point. So we'll draw that in, and then I'll also show you how to do it from the table. So right here, your rise would be 2. And your run would be 3. So this is your slope. Remember, we want to keep this as a fraction. This is our m. Slope is expressed as a fraction more often than it's not, actually. If you look at your table, this is actually adding 2/3 right here. So each time it's adding 2/3. So you can get this from your table also. This is not a great one to find because actually if you have the 0.3 here, it would be at 2, which would give you a lot more information. But that's okay. We could still find it because we drew that line in. So our equation then would be y equals 2/3, not y actually, b of x plus 0. We don't really need the plus 0, so just 2/3 x. So this was our rise of 2 and our run of 3. Go ahead and pause if you don't already have all that written down and get the rest of that written down. Okay, the next one, you guys, is exactly the same. So it says we're going to take f of x, change by a factor, which means dilate, which means multiply by -4. And our new function is going to be c of x. So we're going to keep all the same x values. Remember, they did not do this on here for you this time, so you're going to have to write it in, which on your exit ticket tomorrow, you guys, doesn't have any of this. This is the only thing that's on there, and then the question. So you're going to have to draw this table, and you're going to have to know what to do with it. So we're going to fill in those x values. We have -2, -1, 0, 1, and 2. Those are the same values that they had because I have to use those values to be able to use their y values. Now we're multiplying each of those y's by -4. So we're going to take -2 times -4, which is 8. -1 times -4, which is 4. 0 times -4, which is -4. Whoa, not -4, 0. 1 times -4, which is -4. 2 times -4, which is -8. Now we need to graph these points so that we can get our line. So you have -2, 8, -1, 4, 0, 0, 1, -4, 2, -8. And we need our line. So we put our line in, we need arrows on the end, and this is what it looks like. If you guys noticed, those points that were on the bottom went to the top, the ones on the top went to the bottom. That's because we're multiplying by a negative. That negative is going to make it reflect. Can you guys please write that on your paper? We're going to talk more about that, but that's really what that does. It reflects that over this line right here. We've also got a dilation on there though, so it's going to change those points a little more than just reflecting them. So now we need to identify the slope and the y-intercept. We can do this from our table as well as from our graph. So we're going to do both of those. So our rise here is adding 4 each time. Please write this in your book. Not adding 4, subtracting 4. Sorry guys, subtracting 4. And we can see this on our graph also because right here we're going down 4 units. Our run is adding 1 on our table, and we can see this on our graph because this is 1 right here. So for our slope, we have rise over run. Our rise is -4, our run is 1, and this is the same on our table as well as our graph. So then we just have -4 as our slope. For our y-intercept, it's still just crossing there at 0, so your y-intercept is 0. Remember, we're writing a y equals mx plus b equation, so instead of y, we actually have c of x. This is our c of x function. So c of x equals -4x plus 0, but we don't really have to write that plus 0. So please make sure you have all this written down. If you don't have it written down, go ahead and pause before you move to the next slide. Okay, one other thing I want to talk about, because your exit ticket as well as your test asks this question this way. It doesn't ask it the same as the way it's asking it on here. It asks that with this symbolic representation. So for example, with this one, our factor is -4. It's going to say, given f of x, graph f of x times -4. That's that symbolic representation, and that's what our we will statement was. It was a times f of x. So you would have to know that means multiply all of those y's by -4. With our last one, it would be 2/3 times f of x. The other one would be 4 times f of x. So it's going to ask you that way on your quizzes, your tests, your exit tickets, things like that. The last thing I want to go over is what that a value can do to that function. So it says, For the basic function f of x equals x, the transformed function y equals a times f of x shows a vertical dilation of the function. This dilation affects the output values or y values of the function. These little symbols here, you guys, that are these up and down lines, this means absolute value. If I have a number like -4, if I take the absolute value, it's 4 because it's my distance from 0. If I have the absolute value of 4, it's also 4. So it says if the absolute value of that value you're multiplying by is greater than 1, the resulting graph vertically stretches by a factor of a units. So it's going to stretch that graph out more than it was before. If it's between 0 and 1, the resulting graph compresses. So that means that's going to shrink that graph. So this is going to stretch that, this is going to compress that. If a is less than 0, that means it's going to be a fraction. For example, our 2/3 would be like -2/3. If we had -2/3 or anything less than that, then the resulting graph is vertically stretched or compressed and is reflected over the x-axis. So if you look at this last one, we had -4. That vertically stretched it. It also flipped it over that line that we talked about. It says, compare the values of f of -1 and c of -1. How did the transformation of the function affect the values of the function at x equals -1? So if I go back here, we're looking at -1 on both of these tables. You can see that that stretched that further away. It also changed the sign from negative to positive. So that's what your answer should be in your own words for question 4. That's all we have. Go ahead and put your books away. Remember, you need to put your notebook in your book, and your binding needs to be showing so that your name shows. And then go ahead and get your Chromebook out, and you need to go to Mathia. If you don't have your Chromebook today, you need to borrow one from the bin of Chromebooks that I have, or you need to go, if those are all gone, you need to go borrow one from the library. If you don't have your charger and yours is dead, you need to go look and see if I have one that you can use. If not, you need to go to the library and see if you can borrow one from them. If you need to charge your Chromebook, the sub has complete control over that, you guys. If he says you can't sit somewhere, then you need to move to where he's asking you to sit, okay? You can't just go wherever you want to and sit by your buddies to charge your computer. That's not going to fly. He gets to say where you guys are sitting. Please be respectful because he's going to let me know everything that goes on while I'm gone. So go ahead and get Mathia out and get working on that.